Hi guys, before we start with our new math lesson for today, please don't forget to hit the subscribe button and the notification bell for more videos. So for today, we're going to talk about combinations. Alright, so in the previous lesson, we are able to talk about permutations. But before we go ahead with our lesson about combination, let's differentiate first permutation and combination. So for permutation example, we have the combination to the safe is 472. So for permutation, what we have to remember, it's arrangement of things or objects in definite order. Like for example, if the password of the safe is 472, if you change it to 274, will it open? No, it's not. So the actual password is only 472. So if we have 274, it's a different combination of the password, which is not which will not open the safe unless you will change the password of the safe. And same as well when you are electing class officers, let's say you are starting from president, vice president, and secretary among the 40 students. So we are following a definite order. So we are starting first from the president. We will choose from the 40 students and then followed by the vice president and the secretary. Now, how about for combination? So for combination, example, my fruit salad is a combination of apples, grapes, and bananas. So if I'm going to change the order, let's say if I'm going to put first the bananas and then followed by grapes and apples, is it still a fruit salad? Yes, of course. So the difference of combination from permutation, it is also an arrangement, but it does not care about the order or the position. So for as long as you are giving the arrangement without actually, let's say for example, for permutation, these are two different things. But in combination, these are just counted as one because as you can see, the elements in the first arrangement are also present in the second. So it means in combination, they are just counted as one. We don't care about their position or order. So that's the only difference between permutation and combination. Alright, so let's have our lesson 5.3 combinations. So for my students, you can read more about it from 309 to 314 of your books. Just remember for combinations, it's the selection made from a group of items without regard to their order. So the only difference is the order. For permutation. There's an order or position. We're following certain position. And for combinations, we don't care about the order. So later on, we're going to encounter a lot of problems involving combinations. Now, let's have this. How many ways can two students be chosen from the club? We have Amy, Ben, Dan, and Eva. So we have 4 students or 4 options to be in the club. Now, so first we have Amy, Dan, Ben, Eva. So let's analyze this one. So as you can see, we can pair Amy to Ben, Dan, and Eva, same as well with the others. Okay, so we can also pair Dan to Amy, Ben, Eva. Ben, we have Amy, Dan, Eva, and then Eva, we have Amy, Dan, Ben. So if we're going to count the possible arrangements, we have 12. This is for permutation because we are following certain order. Now, let's analyze this. For permutation, all of those 12 are needed. So for the possible arrangements. Okay? So while for the combination, if there are already repeated elements in one arrangement, they are disregarded. Just like what you were seeing, since we already have Amy, Ben, we cannot have another Ben, Amy. Okay? So I do hope that it makes sense. Alright, so we also have Amy, Eva. Okay? So if we already have Amy, Eva, we cannot have another Eva and Amy. So that is combination. So as you can see, if we're going to count the number of arrangements for combination without following the order, of course, so we only have 4. We only have 6. Where are the other 6? They are just the same as this 6 that you are seeing. Right? So I do hope that you are able to differentiate permutations and combinations. Now, let's have the combination formula. For those who doesn't have their calculator, for you to be able to follow, we have to use this formula. It's being read as the combination of n taken r at a time. So let me change the ink. So it's combination of n elements or the total number of elements or population taken r at a time. So in formula, we have n factorial over quantity n minus r factorial times r factorial. Just remember, the r is the number of uh, arrangements out of the total number of population, right? So this is the formula n factorial over quantity n minus r factorial times r factorial. So in your calculators, it's actually just look for the second function, which is combination of n taken r. It's there in your scientific calculator. Okay? So usually for Casio, it's the second function of the division symbol below or right beside the permutation symbol or the P and R. So here we are using C and R, the combination of n elements taken R at a time. So let's proceed. Let's try this as practice. We have for letter A, we have combination of 7 elements taken 3 at a time. So if we are going to compute for manual, okay, for A, so we have combination of 7 taken 3 at a time. So your n will be 7 and your r is 3. Okay? Now, we have now 7 factorial over 7 minus 3 factorial times we have 3 factorial. So let's simplify or expand 7 factorial. It is 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 minus 3 is 4. So therefore we have 4 times 3 times 2 times 1. Then for 3 factorial, it is times 3 times 2 times 1. Then cancel the same numbers or so we have 4, 4, 3, 3, 2, 2, 1, 1. So and then list down what remained. We have 7 times 6 times 5. Okay, over 3 times 2 times 1. Okay, so all we need to do is to simplify in the numerator and the denominator. 7 times 6 times 5 is 210. Then 3 times 2 times 1 is 6. 210 divided by 6 is 35. Okay, so let's try it. In your calculators, it's 7. Okay, shift, division symbol. So this is the combination of n taken on. Okay, and then the r, which is 3. So the answer is also 35. So combination of 7 taken 3 is 35. How about for letter B, combination of 8 taken 4? Try it on your calculators. Okay, so combination of 8 taken 4 is 70. Very good. Then for letter C, it's a property. Combination of 6 taken 6, n and r are the same. So therefore, this is one same as permutation. Then the combination of 9 elements taken 6 at a time is, what is it? 84. As simple as that. If you don't have the calculator, you can just simply use the formula to get the combination of objects or elements. Okay, so let's have example number 2. So for example number 2, let's read this. You just got a free ticket for a boat ride and you can bring along 2 friends. Unfortunately, you have 5 friends who want to come along. So separate yourself here. So according to the problem, you only need 2 of your 5 friends to be with you in the boat. So it means that the total number of your friends is 5 while you are, so you will take only 2. Okay, so this is a very simple combination problem. So it's now combination of 5 taken 2. So let's see how many possible arrangements, okay, of your friends. Okay, separate yourself. Your n is not 6, rather it's only 5 because we're only talking about the friends or number of friends, which are 5, and you are going to bring with you two of them, right? So combination of 5 taken 2 at a time is we have 10 combinations or arrangements. Okay, as simple as that. All right, so you have 10 possible options, okay, for in choosing 2 of your 5 friends. Let's proceed. Next, example number 3. Omar is packing his bags for his vacation. He has 9 unique shirts but only 5 fit in his bag. So the question is, how many different groups of 5 shirts can he take? So for number 3, so as you can see, you are packing your things or your shirts. So here, how many unique shirts? We have 9. And then for only 5 of the 9 shirts will fit. So it means that we can simply say it's combination of 9 taken 5. Okay, this is very simple. So combination of 9 taken 5 is just 126 combinations or arrangements. Okay, next. Alright, so at a party, each guest shook hands with other guests exactly once. How many handshakes can you make if there are 100 guests? So your N here is 100 because there are 100 hands, 100 guests. But the thing is, how many handshakes? Okay, your R is not yet present, but if you're going to analyze this one, you have to count your hands so that you can shake hands to the 100 persons or guests. So ideally we have two hands. So therefore, we are going to use those two hands to shake hands, okay, to the guest. So it's two. It's now combination of 100 guests taken two at a time because you have two hands, okay? So check your hands. If they are not two, it means there's something wrong. Alright, so combination of 100 taken two at a time, it's 4,950 handshakes or combination. Okay, so the secret here is first you have to analyze the problem before you formulate your solution and solve. Okay, next. So let's have this problem. A basket contains 4 star apples, 5 mangoes, and 8 guavas. How many ways can 2 star apples, 1 mango, and 2 guavas be chosen? So in this case, okay, if you're going to buy fruits, not all of the kind of fruits can fit a specific basket. So we only have to choose at least, okay, to display. Alright, so here, we have 4 star apples, and then you can only put 2 star apples out of 4. Then we have 5 mangoes, and you can only put 1. And then we have 8 guavas, and you can only put 2. So we have more than 2 elements here. So to get the actual or number of possible arrangements here, just multiply all the 3 kinds or variety. So combination of 4 star apples taken, how many star apples? 2 at a time. And then combination of 5 mangoes taken 1 at a time times combination of 8 guavas taken 2 at a time. So just simplify them, okay, multiply them. Alright, so you will be getting, for example, number 5, you will be getting 840 ways to arrange these 3 fruits or combinations. I hope that you understood this specific example. So for my students, if you have some questions and clarifications regarding this, you can contact me. So for those who are watching here, you can just comment down below. Right? So next, generally, the solution goes like this. Alright, so let's have number 6. A 5-member committee is being formed from a group of 9 sophomores and 12 seniors. How many committee consists given each? So A, we have all sophomores. We are forming 5 committee, guys. So if we are forming 5 committees, we have options. We have group of sophomores or second year and seniors 12. So 9 and 12. So for letter A, the restriction is all sophomores. All the 5-member committee, it must be sophomores. So in this case, okay, it's now for letter A, it's now combination of how many sophomores? We have 9 sophomores taken 5 at a time for the committee. So the answer here is 126 combinations. Then for letter B, all seniors. So how many are the seniors? We have 12 taken 5 at a time because we have 5-member committee. So combination of 12 taken 5 at a time, it's 792 combinations or arrangements. Then for letter C, 1 sophomore and 4 seniors. So in this case, we have to choose 1 sophomore and 4 seniors, which will form the 5-member committee. So for the sophomore, okay, we have how many sophomores? 9. Combination of 9 taken 1 sophomore times combination of 12 taken 4 at a time. So for seniors to form the committee, it goes like this: 1 plus 4 equals 5. So the answer here for letter C is 4,455 combinations. And then for letter D, 3 sophomores and 2 seniors. So in this case, okay, it's combination of 9 taken 3 for the sophomores times combination of 12 taken 2 for the seniors. 3 plus 2 equals 5-member committee. So it's now 5,544. Okay, so as simple as that. First, you have to analyze the given problem for you to be able to solve it easily. Let's proceed with example number 7. A box with 12 articles contains one that is defective. In how many ways can Martin select 5 articles such that the defective article is included? So in this specific problem, you have to analyze that we have total of 12 articles, but one of those 12 is defective. And then we are choosing 5 articles out of those 12. So for letter A, we have to include the defective article. So we have to analyze this differently. We have 2 varieties of articles, one defective and the rest are not defective. So in this case, we have combination since we only have one defective, taken 1 automatically. So one of the 5 articles is defective because according to the restriction, the defective article is included. So how many are remaining? We have 4, and then your n is 11. Okay? So combination of 1 taken 1 times combination of 11 taken 4. So if we're going to solve this, we have 330 possible arrangements or combinations. Then for letter B, the defective article is not included. So it simply means that we only have 11 options, and then from this 11, we have 5 articles. So it's a combination of 11 taken 5 at a time. It's 462 combinations. Okay, as simple as that. I do hope that you can follow with our discussion for today. Right? Next, let's have number 8. A bowl contains 6 red balls, 4 yellow balls, and 5 green balls. In how many ways can we select 4 balls wherein 2 are exactly red? So that's the restriction. Among the 4 balls, 2 must be red. But we have 3 varieties. We have 6 red balls. So from the 6 red balls, according to the question, we have to have exactly 2 red. Okay? It's now combination of 6 red balls taken 2 at a time, and then for the remaining, just add the 2. 4 plus 5 equals 9 because there's no restriction for the yellow and green, right? So 4 plus 5 is 9. What the remaining options are 2. The remaining balls that we had to take are 2. Now, combination of 6 taken 2 times combination of 9 taken 2, it will give us an answer of 540 combinations. Then for number 9, of 5 boys and 6 girls must select a 4-person committee. How many committees are possible if it consists of mixture of boys and girls? So the only problem is we are not only using the word any. So it's mixture. It means that from the 4-person committee, we are not allowed to have all girls and all boys. So that's the problem. So there must be at least a girl and a boy in every committee. So we will be subtracting. So as you can see, we have 5 boys and 6 girls. So if we're going to add them, it's combination of 11 taken. Okay, how many? 4. But we have to eliminate those that are all boys and all girls. For the all boys, it's combination of 5 taken 4. And then minus for girls, combination of 6 taken 4. Okay, so if we are going to simplify this, okay, so it's just very easy to analyze that combination of 11 taken 4 is 330. Minus combination of 5 taken 4 is 5. And then minus combination of 6 taken 4, it's 15. Okay, so 330 minus 5 minus 15, we are going to eliminate all boys and all girls. We have 310 combinations. That's it. As simple as that, we have to analyze each problem that involves combinations. And of course, in your examination, just remember that for permutation, we are arranging according to the order or position. But in combination, we don't care about the order and position for as long as we are able to arrange things or elements. Okay, so for my students, please don't forget to do this activity. Right? So I do hope that you've learned a lot for this specific session, most especially to my supporters. Okay, so please don't forget to hit the subscribe button and the notification bell for more videos. So thank you so much and enjoy your day.